Okay, let's continue talking about the motion of objects, and we want to talk about Newton's first law of motion. So Newton actually came up with three laws of motion, and we will see the other two later in our series of videos. We're going to start off with Newton's first law of motion. I thought that you might also like to know a little bit of the history of Sir Isaac Newton. So Sir Isaac Newton was basically in graduate school, and he came back to school and noticed that on the front gate of the school was a sign that said, "Black Death, run for your lives." So during this was like one of the last outbreaks of bubonic plague in Europe. Now, bubonic plague was a very, very serious disease. So it killed like 25% of the population of Europe. So they took this very seriously. Now, one thing though that Sir Isaac Newton had going for him was he was rich. And so he could go back to his country estate and wait it out. So while he was waiting for all the people to die from this last outbreak of this disease, he took with him all of his textbooks. So he took his physics books, his math books, and so for the next 3 years, he was basically studying at home. And so in that time period, he came up with the law of gravity. He figured out what gravity was and was able to explain gravity in a mathematical way. He also came up with his three laws of motion. And then he invented calculus, so an entire branch of mathematics. So my question to you is that if you are going to college and you went to college and you noticed that the college was closed for several years, what would you accomplish? So would you come up with the laws of motion? Well, maybe. But his first law of motion is going to say that every object is going to stay at rest unless acted upon by an outside force. So we could demonstrate this by looking at this pen. So you notice that that pen is stationary and it is continuing to be stationary unless I flip it. So when I flip it, I am applying a force to it. And then notice it does start to move. So if you want to get something to move, you have to push or pull on it. You need to apply a force to it. The second part of Newton's first law of motion is if it is moving, it will move with a constant speed in a straight line unless you act upon it with an outside force. So one way of sorta demonstrating this is with a bowling ball. So when you go to a bowling alley and you see someone take the bowling ball and they're rolling it down the lane, you'll notice it pretty much goes at a constant speed. Now it's actually slowing down very slightly as it's going down the alley, and slowing down because of a force, the force of friction. But you should notice that it tends to go in a straight line and it tends to have a constant speed until it hits the pins. So when the bowling ball hits the pins at the end of the alley, then you notice that the bowling ball comes to a stop. And that's because the pins are going to exert a force on the bowling ball. Now I've got two pictures here, and I want you to try to figure out which picture goes with which statement. So does the picture on the left, does it go with statement 1 or does it go with statement number 2? Okay, the picture there is of a person pulling the tablecloth out from underneath some dishes. This is not a magic trick. It's physics. Now, the heavier the dishes, the better the experiment goes. So the idea is that you're going to have a tabletop, and then you're going to hang a piece of cloth over it, and then you're going to be putting some dishes on top of the tablecloth. And then if you can, you should be able to jerk the tablecloth out from underneath the dishes. Why? So the dishes are at rest. According to which one or two? One, they want to stay at rest, so that you should be able to pull the tablecloth out from underneath them. Now, if these dishes do move, that's because they are experiencing a force. In this case, it would be the friction of the tablecloth on the dish would tend to exert a force on it, which would cause it to move. But the heavier the dish is, the easier it is to do this little experiment. So what about the picture that's on the right? So what's that illustrating? So that one is illustrating number 2, because those are crash dummies. So let's say that you've got a car that's going at 50 miles per hour, and I don't exactly remember what that would be in kilometers per hour, but let's say 50 miles per hour, a good clip, and then it crashes into something. So that means initially those dummies were going how fast? 50 miles per hour. Okay, now after the crash, they keep going. So even though the car has stopped, now why did the car come to a stop? Because it experienced a force. But until the dummies experience a force, they're going to keep on going. So those crash dummies are going to keep moving at a speed of 50 miles per hour until they experience a force. Now, it could be the force of the seat belt that gradually slows them down, or it could be the force of the windshield or the dashboard or the back of the chair that is going to slow them down a lot faster, and we're going to find out that that causes a lot more damage when that happens. So that these two pictures illustrate Newton's first law of motion. If an object is at rest, it will stay at rest unless a force acts on it. If an object is moving, it will continue to move at a constant speed forever and ever in a straight line. So can you see why this would be good if we're talking about rockets? So a rocket ship has to use its engines to get moving. But if it's deep in outer space, it could then turn off its engines and it could coast the entire way to whatever planet it's going to. Now, it's going to have to stop. So once it gets there, it's going to have to turn on its engines in order to slow down and then to go into orbit. But it all has to do with Newton's first law of motion. All right, let's take a break, and when we come back, we're going to talk about what does motion look like in a moving frame of reference.